All right, welcome to part 2. We were getting these inequalities on the graph, and in order to do so, I need to rewrite these in essentially slope-intercept form. So for the first one, all I'm going to need to do is subtract x. So y will be less than or equal to negative x plus 20. And then on the second one, I have a little bit more involved here, and I forgot to put the x here on my 0.05. So first, I'm going to need to subtract the 0.05. So I'm at 0.1y is greater than or equal to negative 0.05x plus 0.4. And now I need to get rid of that coefficient. So I'm going to have to divide everything by 0.01. And what that's going to get me is that y is greater than or equal to negative 5x plus 40. So there are my two inequalities that I need to graph. Again, I'm going to use my two colors. I'm going to start with the first one in pink. And so my intercept is at 20, and my slope is negative 1. And that inequality is underlined, so that one will get a solid line. And it is less than, which means it's going to be shaded below. So everything in here. Okay. For my second one, which I will do in blue, my intercept is at 40 and my slope is negative 5. So that's going to be down 5. And this is scaled by 2s, unfortunately. So 2, 4, 5, 2, 4, 5, and over 1. Oh, and this is scaled by 2s as well. Okay, so back to the start. So I'm starting at 40, down 5 over 1, down 5 over 1, 5 over 1, over 1. I've got enough points that I can connect the dots now. And this one will also be a solid line because my inequality is underlined. And for this one, we are shading above. So my area of interest, where my solutions will lie, is in here, where my pink and blue overlap. Now, any solution to the system would be within that region, but we were given the restriction that at least 10 coins need to be nickels. Now, remember our x is the nickels, so I need to pick an x coordinate that is 10 or greater. So I can't do anything that's along here where it's 8. I have to go 10 or greater. So I'm just going to pick something here like 14, 2. So if I do the point 14, 2, that means I have 14 nickels and 2 pennies. Now let's test it in our inequalities to see if the solution is valid. So starting with the first one, my y is 2, 2 needs to be less than or equal to negative 14 plus 20. Well, negative 14 plus 20 is 6, and 2 is less than or equal to 6. Now checking it in my second equation, inequality. We've been working with equations for too long. 2 needs to be greater than or equal to negative 5 times 14 plus 40. So negative 5 times 14 is negative 70. Negative 70 plus 40 is 30, negative 30, and 2 is indeed greater than or equal to that. So we know our solution is valid. And this one only wanted us to find one possible solution, so we are done. Okay, another tool you can use with these is Desmos. And I will show you quickly how to graph this one in Desmos. You could also go back to example 3 and graph it as well. But the thing about Desmos that's helpful is that I can graph this without having to rearrange our equation like we did previously. So if I go back to my initial one, x plus y needs to be, down here this keyboard is how you get your special symbols, needs to be greater than or equal to 20. And my other one was that 0.05x plus 0.01y needed to be greater than or equal to 0.4, and I apologize, I have this inequality backwards on the first one. Should be less than or equal to. I can see here it graphed it for me. I didn't have to bother with rearranging the equation, and we have that overlapping region in the same place that we got it on our graph. So Desmos is a great tool. You are welcome to use that when working these problems, and that wraps up our systems of inequalities.